Welcome to Circuit 3C, Motion Alarm. So for this circuit, we do notice that we have a bunch of familiar components. We have our distance sensor, which is our only input, and we have three outputs. We have our piezo buzzer, which is a speaker, our RGB, and our servo motor. Keep in mind that all of these components here are polar. The way that we connect the wires is very important, so make sure you know what is going to ground and what is going to your pins. Remember that there are a lot of wires in the circuit, so take your time as you add each wire. Upload your code, check if the circuit works, and if it doesn't, check your wires, check your components, see if they're placed the right way. So after uploading your code successfully, you're going to notice that when we start covering the distance sensor, our RGB starts going from green to yellow to red. And we also notice that when our RGB turns red, our piezo buzzer turns on and our servo motor starts going crazy. So for this circuit, I will not explain how the RGB works, how the buzzer works, or any of these components work because we've already explained this in other circuits. However, if you do find that your RGB is not turning on, try to flip it to make sure that your longest leg is connected to the black wire, since that is your negative leg. In addition, if your buzzer's not working, it's also probably connected the wrong way. As far as your servo motor goes, make sure it's connected correctly as well, and it could be a wiring issue at first. From lines 16 to 23, we are just identifying the pins that we're using, and we are creating variables to be associated with each pin. Lines 16 through 17 relate to the pins going to the distance sensor. So remember, with the distance sensor, we do send a pulse out, and we receive a pulse, and we measure that distance that the pulse traveled. Pins 3, 5, and 6, or lines 19, 20, and 21, are related to the RGB. Line 23 is related to the buzzer pin. And we always start off with a distance of 0. We are also including the servo library, and we also identify that our servo is called my servo. In void setup, we are identifying what is an input and an output. Notice that we only have one input, which is that pulse that is being received, and we are measuring that. So we send out a pulse, and we receive a pulse, and we measure the distance that the pulse travels. We have our RGB as an output, our buzzer as an output, and we identify what pin is associated with our servo motor. Notice we identify the pin that is associated with our servo motor in void setup. In void loop, we have, let's remove the buzzer. It's getting annoying. So in void loop, this is where the magic is happening, and we are running our code over and over again so we can actually make all of these components work right here. So for instance, we do have our distance equals get distance. So get distance is a calculation that is performed far below. So we don't mess with this unless you want to convert your measurement to either feet, inches, meters, whatever you want. However, up here, we are printing out our distance. So let's actually turn on our serial monitor. And notice we have different measurements here. I am just away from measuring at 10 inches. So that is why my light is at yellow. That if our distance that we measure is less than 10, we only activate our red pin. We turn on our buzzer, and we make our servo motor go to 10 degrees for 100 milliseconds and then rotate to 150 degrees for 100 milliseconds. That's why it spins really quickly. Now, if we measure an object in between 10 to 20, then we do turn on our yellow color by mixing red and green. If we do not measure a distance at all, less than 20, then we only turn on our green light, and we are repeating this quickly at 50 milliseconds. For challenge number 1, change the servo behavior. Try changing the way that the servo behaves when the distance sensor is triggered. So all we're going to do is just change the way in which the servo moves. So we first have to identify where our servo is turning on, and we do know that it turns on when we measure a distance of less than 10. So in this situation, we're going to change it to move slower. I'm going to add a 0 to the delay so that my servo stays at a certain position for 1 whole second. And I'll do the same for the other position. We can also adjust the way in which the servo turns, but we recommend that you keep the servo in between 10 to 170 degrees. If you go from 0 to 180, which is the maximum and the minimum degrees that the servo can turn, the servo may start twitching. So this is what we have before, and pretty soon we'll start seeing it move slower. So in this situation, our servo is now turning at a slower speed, and it'll be more tolerable to work with. For challenge number 2, change the alarm settings. Try altering the code so the alarm goes off from a much further or closer distance. So in my situation, I'm going to change it so that the alarm goes off at a closer distance because I'm getting tired and annoyed of the buzzer going off and the servo moving when my mouse gets too close. So in this situation, I'm going to change my distance so that if I measure an object less than 5 inches, notice we are measuring in inches, then my red color will turn on and I'll turn on my buzzer and my servo motor. So in this situation, I'm also going to reduce my else if distance so that we turn on our yellow light from 5 to 20 inches. So in this situation, we are measuring an object that is 11 inches away, 6 inches away, and notice our light is still yellow and our other components are not turning on. But if I go down below 5 inches, our red light turns on, our buzzer goes off, and our servo motor starts rotating, but slowly. Also notice that we are now either turning on our buzzer for 1 whole second or keeping it off for 1 whole second, because we are running this code together for this amount of time. For challenge number 3, you're just using the servo motor to create a mechanism so that you can either feed fish, or in other cases you can also create a prosthetic can. For instance, right here, the way that this is wired up, I have a servo motor attached to a cardboard box. I have some components over here, and pretty soon this will be a prosthetic hand, so watch out for that. So I won't be doing anything with this at the moment. Try it out on your own.